Welcome to Project Metis. Project Metis will focus on the speculative evolution of 3 habitable moons of the gas giant Metis. The gas giant and its collection of moons orbit Zeus 135 within the habitable zone. Named after the first wife of Zeus, Metis is a protector of 3 unique life-sustaining worlds, Athena, Nike, and Eric, short for Erichthonius. Metis protects against any large collision events with its massive gravity while also holding its moons close enough that the gas giant causes tides and tectonic activity within the planet due to its immense gravity field. This combination of protection, geological activity, and tidal forces have helped to create a sanctuary for life on the moons of Metis. Currently, Erichthonius is a relatively barren world devoid of life on its surface. However, life on this strange moon has evolved to live in the subterranean environments of Eric. As Eric now orbits Metis, the internal layers and activity of the planet have been renewed by the gravity of the gas giant. Volcanic activity slowly begins again on the planet, aiding in its development of an atmosphere and causing the global temperatures to rise, allowing for liquid water to exist again on the surface near the polar caps. This period of the reawakening of Eric is known as the Age of Anastasi. This time of resurrection is characterized by the growing volcanic activity of Eric, the reemergence of the electromagnetic field, and the formation of a more hospitable atmosphere. The current life of Eric are a small fraction of the life once present throughout the once lost world. The descendants of the Zeuspilian, the theorized common ancestor to all the respiratory life of Eric, can be found throughout the tunnels of the underground in several different surviving clades. These clades are divided by the body types of these cave organisms. The first clade we see in the shadows of Eric are the shimia. These organisms are characterized by the tentacles on the front parts of their bodies, while having geometric soft exoskeletal structures around the greater part of their bodies. The creatures are extremely small, often almost microscopic, and feed directly off of the chemosynthetic organisms of the Eric waters. The shimia split into the one-eyed Cyclopus and the two-eyed Diamatia. This difference in eye structures is evidence that these organisms originated in a domain once abundant in light, and it seems the Cyclopus adapted to the low light conditions of the underground but losing photoreceptors to develop only one primitive eye. The chalik are a clade described for their many legs and segmented bodies. The endemo are the most widespread of all of the chalik and make up a majority of the biomass of Eric. These insect-like organisms have radiated throughout the tunnels to occupy the few niches that still exist in the caves. The endemo feed on the various bacteria and photosynthetic organisms of the rocky caverns. The endemo will further adapt to the environment and will divide into groups that contain families of hive-forming organisms that will not only learn architecture to further develop their tunnel hive systems, but they will also discover how to cultivate various species of microbes for food. Meanwhile, the Characterized are a group equally as widespread as their endemo cousins, but these organisms feature horn structures on their heads for defense and for use in digging for food. These creatures also show evidence of once being a surface-dwelling species as they have basic wing structures on their backs. These structures, however, are no longer functional as a mode of flight. The piscal are children of Eric with long segmented bodies that have many legs for traveling the rocky terrain of the caves. The piscal divide into the malleuscal and the leuscal. The malleuscal are small, and exempt many hair-like filaments that aid in sensing and smelling in the darkness of the underworld. The malleuscal are often seen in mass consuming vast quantities of cavern flora before migrating to a new location in search of food. The leuscal take on a predator niche as the hunters of both the endemo and malleuscal. These slender, stealth creatures are often found stalking in the darkness for anything to pounce on. The leuscal are also known for their ability to slow their metabolism to allow for longer periods of sleep before requiring more nutrients. The kmpi are the last of the fish-like organisms of Eric. Many of these creatures can breathe in both the air and water, allowing these organisms to travel between isolated areas of water to assist in genetic diversity. This group is also mostly small in size, and vary in diet. From scavenging to predation and even the herbivorous niche, the kmpi will adapt into 2 new varieties. The Dontipsari are the predator members of this class. The Dentipsari have sensitive antennae on the facial structure to help with locating prey in the dark, and they have also evolved to have 4 eyes to see bioluminescence in the darkness. Each pair of eyes see different light frequencies to even help locate any type of glowing organisms. The Cephospsari have a more generalized diet, and so lack the sharp teeth of their cousins. The Cephospsari have a long development into adulthood, as each stage of their growth allows these creatures the opportunity to occupy multiple niches to limit interspecies competition. The young of the Cephospsari feed on the microbes of the cavern waters. As they age and obtain the ability to travel over land, the Cephospsari learn to hunt Entommo on the rocky cavern floors until they are large enough in adulthood to eat smaller individuals of their kind, or they will learn to eat other children of Erich. Finally, the apex predators of the underworld of Erich are the Neurodracon. These amphibious creatures dominate the caverns of Erich as the top predators, as they have the best locomotion over the rocky surfaces while also being exceptionally strong swimmers. They also have filaments that aid in respiration underwater, but these creatures can also breathe the air that fills the caverns. These amphibious predators radiate into 3 different types. The Microstracus are the smallest of their family. These animals fill the small predator niche and consume the Entommo and juvenile kmpi species. The Microstracus also have egg structures that are better at retaining water than their larger cousins, allowing this group to hide their eggs away from predators in drier locations. The Microstracus also adapt through the Age of Anastasi to obtain nutrients from rocks. Some species of the Microstracus form a symbiotic relationship with chemosynthetic organisms that live within a special organ of their body. These amphibious rock eaters are able to share nutrients with the bacteria from not only the rock, but of the micro-extremophiles inside the as well. The Prasinadraco have adapted to be omnivorous, and have evolved to feature a green tint to aid in ambush attacks against aquatic creatures in the cavern lakes. As the Age of Anastasi continues, these predators will adapt to have venomous saliva and poisonous mucus, as they will also form a relationship with extremophiles that help them generate chemicals to help them in self-defense. The Megalostracus are a bizarre species that have long filaments for respiration and for consumption. The Megalostracus have learned to filter feed the microorganisms in the underground water supply, and they have developed the ability to respirate in both the water and air. These ultimate predators of Erich consume almost any organic matter available to them unchallenged in the underworld. As the Age of Anastasi continues, Erich will show signs of life on the surface, but of a different origin. Next time we will explore the end of the Age of Anastasi, and we will investigate how life from Athena fell to Erich to help jumpstart the ecosystems into a new age of evolution. We will explore the vast cavern types throughout Erich, and we will see how a world is reborn. Until then, never stop exploring, and never cease to wonder what this beautiful universe may hold. Thank you for watching, and make sure to like and subscribe to check out future entries for Project Metis.